I would like to welcome Sri A.S. Kiran Kumarji, our distinguished keynote speaker of today's special webinar organized by Gujarat Student Startup and Innovation Hub, iHub, and Department of Higher and Technical Education, Government of Gujarat. He was the former chairperson of ISRO, Indian Space Research Organization, and he has spent considerable time, rather 4 decades in Gujarat during his professional work. And none other than him could really guide us how institutions are built, how innovation get embedded into the DNA of institutions, and how inclusive growth of country are dependent on how innovative we are and how enterprising we are. So I also like to welcome Shri Nagarajan, Commissioner of Higher Education, Government of Gujarat, and Honorary Executive Director of iHub. So both of them are going to throw us some ideas, and our keynote speaker, Sri Kiran Kumarji, is going to share the experience of his journey and the journey of ISRO in promoting harnessing innovations. ISRO is one of the rare institutions which has made the legacy of taking innovation to mass, innovation for public benefit, and the country has significantly benefited out of it. So having said that, I would now request Sri M. Nagarajan, Commissioner of Higher Education, to give his welcome address.
Thank you, Hiranmay. It is indeed one more beautiful session that we are having with Shri A.S. Kiran Kumar sir on our podium. We are glad to have him here because he has been in the cutting edge of science harnessed for societal benefit. And we have seen the role of science and technology that has shaped the lives of a billion people of India. And he has seen it all across so many decades of his experience. So we are happy to have him here to motivate and inspire our principals, our mentors, and our assistant professors and professors who are guiding the students on innovation and startup. And also other important thing is that space technologies. Other important thing is that space technologies, which is gaining a lot of traction, and now new startups are coming. Once upon a time, launching a satellite used to be an affair that only big sovereign nations could do, and ISRO did a very leadership role in that. Now there is a sort of democratization of technologies, and even young student startups are aiming to do satellite launches, nano satellite launches, and rockets and other things. The entire enterprise on space is also getting more commercialized in that sense. So we can actually track the journey of science and technology across the decades in our conversation with sir today. He is a Padma Shri and he has won a lot of awards, and he has been a very distinguished intellectual and person. So we are happy to have him here, sir, on behalf of Education Department and all the students, innovators, and mentors who are guiding the student startups. I extend a very warm welcome to you on this session. Thank you for joining us today.
Thank you, Nagarajan sir, for doing the honor. I would now like to formally introduce Sri A.S. Kiran Kumarji to all our listeners. This talk is being broadcasted to all the innovators and entrepreneurs. We have supported more than 3,000 student innovators by now. They all will be really beneficial to this talk, from this talk. So Sri A.S. Kiran Kumar sir is Vikram Sarabhai Professor at the Indian Space Research Organization at Bangalore. He is member of the Space Commission, Government of India, and member Governing Council, Indian Institute of Science, Bangalore. During 2015 to 18, he has served as the Secretary, Department of Space, and Chairman, Indian Space Research Organization. Sri Kiran Kumar was born on 22nd October 1952 in Hassan in Karnataka. He obtained his physics honors degree from National College, Bangalore in 1971, MSc Physics and Electronics from Bangalore University in 73, MTech degree in Physical Engineering from Indian Institute of Science, Bangalore in 1975. He has steered the implementation of applications-oriented Indian space program, which Nagarajan sir was just mentioning about, which has facilitated rapid development of country in many important spheres of the earth observation, communication, navigation, meteorology, and space science, as well as the development of indigenous launch of vehicles and related technology for providing assured access to space. He has contributed to the design and development of more than 50 electro-optical imaging sensors, flown on space-borne platforms starting from Bhaskara TV payload in 1979 to payloads on board the Mars orbiter mission in 2013. He has played a critical role in Chandrayaan-1 mission right from the conceptualization stage and has made exemplary contribution to the success of Mars orbiter mission, which is famously known as the MOM, and reusable launch vehicle technology demonstrations, which is called RLVTD. Shri Kiran Kumar has been the chair of the Committee on the Earth Observation Satellite, CEOS, in 2012. He has made valuable contribution to the Coordination Group of Meteorological Satellite, CGMS, Expert Team on Satellite System, World Meteorological Organization, and Indo-US Joint Working Group on Civil Space Technology. Shri Kiran Kumar is President, Aeronautical Society of India, Fellow of Indian National Academy of Engineering, National Academy of Science in India, Indian Society for Remote Sensing, Institution of Electronics and Telecommunication Engineering, Indian Society of Systems for Science and Engineering, Indian Meteorological Society, Indian Society of Geomatics, Gujarat Science Academy, Andhra Pradesh Academy of Science, and elected member of International Academy of Aeronautics. He has been conferred a DSc by 18 Indian academic institutions. He has co-authored 85 publications in various national, international scientific journal, conferences, and symposium. In recognition to his contribution, he was conferred Padma Shri Award by President of India in 2014. The government of Karnataka honored him with Rajyotsava Award for the year 2015 for his contribution to space science and technology. Sir M. Visvesvaraya Senior Scientist Award for the year 2013 and Lifetime Achievement Award for Karnataka Science and Technology Academy, KSTA, in 2016. He is recipient of Indian Institute of Science Distinguished Alumnus Award in 2015, Gujarat Ratna Life of Innovation Award conferred by Gujarat Innovation Society in 2014, and Lifetime Achievement Award by Andhra Pradesh Academy of Science in 2016. Bharat Ratna Sir M. Visvesvaraya Centenary Award for Innovation in Technology conferred by University of Mysore in 2016, GM Modi Science of Award by Gujarmal Modi Science Foundation in 2016. Many more awards are there in the list, and from these you can definitely gauge the kind of work he has done in the entire journey of his professional path of space technology. And one thing that I must add in this sense, I had an opportunity to interact with Sir during many occasions during the innovation and other activities in Gujarat. And I must say one thing, that you never get more humble, more simple human being with an extraordinary heart and head together. So Dr. Kiran Kumar, welcome you today to this special session on behalf of the entire community of innovators, startups, all principals, vice chancellors, all of them who are listening to you. I am lucky to have you today to have this special session to all our audience. I would now like to request Kiran Kumarji to start his presentation.
Thank you, Hiranmay, for that introduction. And also thank you, Nagarajan, for giving this opportunity to be part of Gujarat Innovation Hub and then make sure that Gujarat, where it's actually my karma bhumi, because I spent 40 years of my life in Gujarat. Just a second before I start my presentation. And at the outset, I would like to thank both Hiranmay and Nagarajan and Gujarat government for giving me an opportunity to be part of this journey, where Gujarat is actually showcasing to the country how innovation needs to be promoted and innovation needs to be actually supported for the development. And what I intend to do today is take you through the journey of ISRO during the last 5 decades, and through that showcase to you how many of the innovations have become part of ISRO's activities. And toward the end, we'll also look at what are the ways in which innovations can make a difference to the country. So probably we all remember the gentleman, the son of the soil, Dr. Vikram Sarabhai, who actually is the father of our space program. And it was his vision and his foresight which enabled the country to adopt one of the newest technologies which became available in the late 50s. And it was his point that our national goals involve leapfrogging from a state of economic backwardness and social disabilities, attempting to achieve in a few decades a change which has historically taken centuries in other lands. This involves innovation at all levels. And it was Dr. Sarabhai whose vision actually looked at using the space technology for national development, which involved capability demonstration, capacity build-up for harnessing space technology to meet national and societal and strategic needs, and also to be a significant player in space economy. Actually, I'm sure you're all familiar that way back in 1957, in the month of October, when the first object was put into space by Russians, India was a fledgling economy, democracy, which was just 10 years old, and it was grappling with the problem of poverty and development. And it was the effort of Dr. Sarabhai which enabled India to start working in this new area of space technology, where by putting objects in space, you can look at what is happening on Earth and also connect the entire population on the surface of India through satellite communication. And he, with the help of his friends from France, Germany, America, and Russia, he brought in sounding rockets. And on 23rd of November 1963, the first launch took place in India of a sounding rocket. One of the things Dr. Sarabhai did initially was to convince the government of India that we need to conduct an experiment called Satellite Instructional Television Experiment, wherein we borrowed a satellite from America, one of the most advanced technology satellites. And that satellite was moved over India. And during 1 year in 1975, the organization was able to demonstrate to the country in about 2,400 villages of 6 states, covering more than 2 lakh people, the benefits of space-based broadcasting service. Though Dr. Sarabhai himself did not live to see this particular experiment, his efforts of making use of the space technology for demonstrating to the country worked. And in fact, it was India which actually did an innovative use of this advanced technology satellite which Americans had built and showcased to the world in one of the world's largest socio-technological experiment conducted at that point of time. What was done in this is equivalent of today's direct-to-home television sets were built in Space Application Center Ahmedabad at that time, and using that in these 2,400 villages, direct-to-community sets were used and villagers were provided the benefit of receiving information from satellite broadcasting. Another very important thing which Dr. Sarabhai had done at that time was he convinced his friends that India, by virtue of a unique geomagnetic equator being present close to Tumba, if we conduct upper atmospheric research here, it will be beneficial for the entire global scientific community. With that, he could bring sounding rockets in the form of kits, and in fact got assembled in the church, what you are seeing here. And for conducting that experiment at that time, he had to convince the fishermen in that region with the help of the priest there, and telling the fishermen that if you vacate this place and allow us to conduct the experiment, one day in future the country will benefit. Though to demonstrate this, from 1999 onwards, India was able to provide to the entire fisherman community almost 7,400 kilometer long coastline what we have. In that, using the color of the ocean observed from the satellite instruments, and then looking at the chlorophyll, and through that the food chain of the fish, identifying prospective fishing zone, and this particular information being provided to the fishermen through the Indian National Center for Ocean Information System was being done with this prospective fishing zone map. In addition to this, what India is able to do today is make use of its own Navi constellation of developing its own GPS system. And we have a unique messaging capability in this satellite. Today, a small gadget which is battery operated is fitted into the boat of the fisherman. And this gadget communicates with the mobile in the hands of the fisherman through Bluetooth or Wi-Fi. And an app on the mobile of the fisherman helps him communicate in his mother tongue, alerts about weather vagaries. More than that, on the mobile, through a video compass, he gets direction where to go for fishing. Not only that, in presence of weather turbulences, he gets warning in his mother tongue, and if he crosses international boundaries, he gets alert. You can see in this example how the most advanced technology of rocket building satellite instruments are used to provide the intrinsic wherewithal for a person who need not know reading or writing and can make use of a mobile in his hands and carry on his livelihood. In the similar manner, the capability of this space technology was used, actually is currently being used to demonstrate, not only demonstrate, make operational in terms of super cyclones, where in the earlier era, we used to have tens of thousands of people losing their lives. Today, by virtue of this information, India is able to provide disaster relief agencies with an advance information 4 to 5 days in advance, accurate positioning and the time of landfall of the cyclone. And through that, the country is able to save thousands of lives. Starting from the initial exercise of sight, continuously India demonstrated at that time to the government that we should make use of the space technology for communication, broadcasting, and meteorology. And India came up with a unique 3-in-1 satellite in INSAT-1, which had telecom, communication, broadcasting, and meteorology 3-in-1. And in fact, at that point of time, nobody had actually built such a satellite. And we had to do it because we were not having enough resources to put 3 separate satellites and 3 separate launches for doing that. But though at that point of time, we did not have the technological wherewithal for building that satellite, we got this built from an American firm. But from 90s onwards, we have been building INSAT 2 series, 3 series, and 4 series satellites, all our own. And today we have more than 15 satellites providing communication, broadcasting, and we have also got high throughput satellite and connectivity for whether it is for direct to home television or telecom services. This is being provided. And using realization of technology, using opportunities available in the remote sensing area also was what was demonstrated by ISRO. Early experiments of conducting what was called coconut wilt disease experiment by flying a Hasselblad camera borrowed by an American institution, and then using this, demonstrating that satellite-based remote sensing can make a huge impact. And we made use of the opportunity provided by the Russians to fly the Aryabhata and Bhaskara satellites, and then later using commercial opportunities. Today, all remote sensing satellites in the country are built within the country. And in the communication, starting with INSAT 1, INSAT 2, so we have up to GSAT 11, GSAT 29. We have a host of capability, multi-beam satellite providing broadband connectivity and a significant number of different frequencies. We have this capability. Another very interesting and innovative approach in solving the problems was the way we adopted GPS system to provide solution to India and surrounding India. In addition to this, we also had a GPS-aided geo-augmented navigation system where India filled the gap of the global connectivity in this area. And today, it's a work where in ISRO and Airports Authority of India, Director General of Civil Aviation has made this service mandatory. and all aircrafts registered in India need to carry these Gagan-enabled receivers, and with that, they'll be able to do en route planning as well as precision landing activities. This is being used. And similarly, in navigation, unlike what Americans, Russians, Europeans, and Chinese have done of using between 24 to 32 satellite constellation, we came up with a 7 satellite constellation to provide our own intrinsic navigation system using a small receiver telling where we are in terms of location, and this beyond the Indian boundaries up to 1500 kilometers, this system has become operational, and today a large number of services are possible using this. Mobiles are coming with Navic enabled capabilities, and a number of companies are working on providing solutions using Navic systems. In addition to that, like you can easily imagine from space, when you look at Earth, you can collect a host of information about different aspects. We have been building satellites, and today we have a capability of providing sub-meter resolution imaging in various wavelengths, visible, infrared, and using this, various applications are being done. And then meteorological satellites like providing for weather forecasting. Many of you will also be wondering, see from space when you are looking at in optical and infrared domain, during the months of June to September, India has clouds, and what kind of observations will be possible. Use of microwave signals enables you to penetrate through clouds, and we have also built microwave technology hardware, both synthetic aperture radar as well as scatterometer, which provides specific information on ocean wind vectors and atmospheric weather parameters for various activities. And we are providing this not only to India and also to the global community. Today, by virtue of the satellites that are built, we have digital elevation model of the country, data in different multi-spectral, multi-temporal information, optical and microwave, navigation-based positioning system, and using the mobile data collection platform, models and techniques, a set of activities of economic security, socio-economic security, suitable, sustainable development, disaster risk reduction, and governance in all these activities. We have been enabling a host of central and state government departments in using the space application data for their work, whether it is biennial forest report or for potential fishing zone for Ministry of Earth Sciences, or about 11 crop types, making harvest ahead of harvesting, what is the yield and what is the production of various crops, and civil aviation. And in a couple of years back, Honorable Prime Minister conducted an event where the state and central government secretaries of the various departments were brought together, and we showcased to the entire community how space technology can be used for various applications. In fact, Honorable Prime Minister on that day spoke 45 minutes extempore to tell the people, tell the various officers how space technology can be used in governance and various activities. And with that, a significant flip to the use of space technology happened. Leapfrogging, which was one of the Sarabhai's vision of trying to make use of this technology for doing the technology development. Leapfrogging, as you can see, is if you take a normal process, you have to, if you go to high jump, then you have to prepare yourself, run a long distance, build enough momentum, and then transfer that momentum to your height. Whereas in the case of a frog jumping, it crouches, focuses all its energy, and then does. Similarly, in India, when you have little access to international technology and also particularly high technology area, where many of the things by virtue of being dual use technology is not accessible to you, you have to build your own solutions to many of the problems. And what ISRO has been doing is right from the beginning, whether it was a site where it showcased to the world, conducting the world's largest socio-technological experiment, or building highest resolution imaging in civilian domain, or Mars orbiter mission, which was again, you will see in some of the subsequent slides, a very different way of conducting an interplanetary mission. Astrosat, an astronomy satellite, where India has made a huge impact globally. You will see in a subsequent slide. And also, when we launched 104 satellites in one single launch using our PSLV, the entire world took note of the development that was happening. It was this basic idea of Dr. Sarabhai of enabling the technology of space for using it to solve our country's problem, which has been the driving force in ISRO's innovative approaches to solve the problems. Today, whether it is the railways, which makes use of both the navigation and the communication capabilities built, you would have seen recently in the papers, railways saying that they're able to improve their efficiency and also provide in unmanned level crossings the technology of making use of communication and remote activities, and then providing MSS network for coastal surveillance, and similarly making use of these capabilities of using synthetic aperture radar. And here you can see the ocean wind vector information. You can easily visualize on a globe, a significant amount of the globe is covered with ocean. And if you do not have in situ data of that, with numerical weather models will be handicapped. And today we are actually providing this ocean wind vector information to the global community through our satellite-based system. And ResourceSat, you are able to generate a 3D model, fly-throughs, and you can easily visualize the kind of advantage this can provide to the various user community in the country. And then renewable energy inputs from space. In fact, places like Gujarat, where you can actually pinpoint and tell over a year what is the amount of sunlight that will be available for establishing solar plants, etc., or whether it's offshore wind energy or with respect to the wave energy. All these information can be generated based on the satellite data, and using the operational as well as various satellite data for providing disaster monitoring and disaster relief, whether weekly rainfall map or forest fires, they can all be detected. And you can also see here, for example, how you can actually visualize the iceberg breaking and then study the things that are happening globally, whether it's Arctic or Antarctic. And here again, you can see in the Himalayan Koshi Basin how the glacier melts and the lake which gets formed keeps increasing. And with time, you can make a study, and then you can also make use of such data for providing alerts in case of what can happen in future. India, true to its tradition, also has showcased to the world that knowledge acquisition and technology acquisition should be used not only for your benefit, but also for the benefit of your neighboring countries. In fact, South Asia satellite was a unique demonstration by India of providing the satellite communication capability to our neighboring countries. And in fact, on the day this particular satellite was launched, the Honorable Prime Minister had brought together the heads of states of all the countries, neighboring countries. And what the Afghan president told at that time is a matter of pride for all of us. What he said was that we are used to people making promises, and this is the first time I'm seeing a promise made being fulfilled in real quick time. And today, a number of these countries are taking advantage of this communication capability being provided. And then while all this was happening, India also worked on space science right from its initial satellite of Aryabhatta. Today we have Chandrayaan 1, Chandrayaan 2, Astrosat, and then a number of future satellite programs. And we have been working on various orbits, whether it's a low Earth orbit for putting satellite for providing communication, remote sensing, or geostationary satellite, which is up to 36,000 kilometers, then moon, 3.85 lakh kilometers, or Mars, when it is closest, about 225 million kilometers, and when it is farthest, about 400 million kilometers. And we have been able to put satellites into all these locations. And then in doing this, we have encountered various kinds of orbits, the polar orbits, equatorial orbits, inclined orbits, and also we have made innovative use of these orbits to acquire additional energy for the satellite to conduct the various tasks of going farther from Earth's gravity, reaching Moon and Mars. And in all this, very innovative applications and usage has been demonstrated. And what the globe has seen is that it is possible to conduct very different way in a cost-effective and timely manner various activities. Chandrayaan-1 was in fact an excellent demonstration of how an internationally cooperated mission can be done. And Chandrayaan-1, which was launched in 2008, demonstrated that about 5 countries providing a number of their payloads was put together in this. And India, actually, the Chandrayaan-1 gets the credit for discovering the presence of OH and water molecules on Moon. In fact, you would have seen just a couple of days back, scientists who have been studying the Chandrayaan-1 data have also shown that rust formation on the surface of the Moon is probably happening, where while the iron was present, the presence of moisture and oxygen also is happening, and rust has formed, and the data collected by Chandrayaan-1 has been providing excellent inputs to the various scientific community. Mars orbiter mission is again a very successful demonstration of the capability that India developed. In fact, in this, what we were originally planning was to have this satellite go around Mars for about 6 months. In fact, come this 24th of this month, we will be completing 6 years of operation of the Mars mission, while originally it was planned for 6 months, because we had to make all the capabilities of the satellite to be able to travel almost 600 million kilometers after leaving Earth, and then traveling this entire distance, enter into the Mars atmosphere in a highly elliptical orbit. The original plan was for 6 months, but today we have completed 6 years, and during this period, a significant amount of data has been collected, and scientists are continuing to work on this data to study what can be done. And then one other very important development, which many of you will be really proud of, is the AstroSat. As you can easily visualize that when you start looking at celestial objects from Earth, atmosphere comes in between, and this atmosphere restricts the ability to see in fine detail what is actually present or what's happening in the celestial objects and events. A star which is seen from a very high capacity telescope on ground, which looks like this, can be seen with this kind of detail using a Hubble telescope. But what India has done using its AstroSat, wherein ISRO enabled many academic institutions in the country, whether it is Tata Institute of Fundamental Research or Raman Research Institute or the IUCA Inter-University Center for Astronomy and Astrophysics, Physical Research Laboratory, Indian Institute of Astrophysics. Using all their laboratory capabilities, many instruments were built, and this satellite, which was launched in 2015, and in fact, this particular telescope, what you are seeing, UV telescope, which has a capability to see in 100 to 500 nanometer, is the one which has made a huge difference to the observation capability. And Indian scientists have discovered ultraviolet wings of butterfly nebula, and they have also shown for first time some X-ray polarimetry, the activities happening on Crab pulsar, and also on the black holes. the showcasing that these black holes spin at very high rates, which was predicted that it was able to measure. And more than that, just a couple of days back, it was demonstrated that India's first multi-wavelength satellite, AstroSat, which was launched in 2015, was able to achieve a distinction of detecting extreme ultraviolet light from a galaxy called AUD-FS01, which is 9.3 billion light years away from Earth. In fact, this is possible because this particular telescope, what you see, is today the world's highest angular resolution telescope and also has highest sensitivity. Though Hubble has much larger aperture and capabilities, this provides in a particular wavelength better sensitivity. And using this today, the Indian scientists have been able to show that signals emanating from what is called as the dark age, or just prior to the first lights emerging from after the Big Bang, has been detected. And the team led by Dr. Kanak Saha, Associate Professor in Inter-University Center for Astronomy and Astrophysics, led a team of scientists, and using almost 100,000 seconds of observations using this AstroSat satellite, this detection has been done, and many more such results are likely to come out in future. And this is, again, you'll be happy to know our Chandrayaan-2 carries one of the very high resolution imaging systems and the kind of details one we can get using Chandrayaan-2. And in fact, we just completed 1 year of orbiter operation using Chandrayaan-2. And using this, we have got a number of observations made in whether it is the camera which is capable of doing the elevation models of the moon surface, or using the observing using the high resolution imaging system, or making the X-ray monitor, detecting certain metallic metals or OH or various molecules. And then we also have L and S band SAR, which can actually see permanently shadowed regions on the surface of the moon. In fact, today you'll be extremely happy to learn that all the instruments on Chandrayaan-2 are improvements over the previous Chandrayaan-1 capabilities, and it has got such tremendous potential that data from this is going to make a huge impact in both research and scientific community in the coming days and years. And we also have an imaging spectrometer operating up to 5 microns, and it is providing excellent results. And these data will be made available to the user community, and they will continue. In addition to all this, India is also working on space mission, where the manned mission, where the Gagannauts will be carried from India on these capsules, taken to space and brought back safely. And this mission ISRO is working on. So during this period, what Sarabhai's vision of using space technology for national development, what India has demonstrated is a capability demonstration, but now what is required is capacity building and for increased scale of operation of all this. And if this has to happen, what is required is, earlier India concentrated on this people-centric application-driven activities of building space infrastructure, space transport, capacity building. And now we also need to look at space commerce, because today space is the fourth frontier, and there is a huge opportunity for India to be a significant player in the space economy, which is touted to be around $400 billion in the coming years. And India, with its ecosystem of this technology development and innovation, can become a significant player in this. And that is what the government of India is trying to enable the various facilities and the capabilities developed by ISRO during this period being made available to the user means both the entrepreneurs, industrialists, and academicians to make use of and go ahead. I'll just run through a set of slides which shows the kind of the facilities that have been built to make see academic institutes, space technology. If we have to make the country make use of this technology for future, we need to interact with all the segments, and this is where in India both the government and the ISRO, the Department of Space, is endeavoring to move ahead in this. Okay, having told you all this, let us also look at what we are seeing today or what we are discussing today, the people. See, this was, I was just while going through some time back, how people look at what has been happening in India. For example, this was way back in 2016, and one of the persons, George Isa, he wrote, "Is India's ISRO disrupting global space exploration and launch missions?" In fact, this was even before our 104 satellites was launched. So he was talking about how ISRO has of late become a force to reckon with, displacing the India's world's top industrial giants. A disruptive innovation is an innovation that creates a new market and value network and eventually disrupts an existing market and value network. And if you look at innovation, what it means is a sophisticated technology that simplifies, provides simple solutions to a problem, low cost, innovative business model, or economically coherent value network, regulations and standards that facilitate change. In fact, what iHub will be actually operating is in this domain. A disruptive innovation, we already talked about what it is. He said, Indian Space Research Organization is in the throes of entering into a phase of disruptive innovation by offering low-cost launches. In fact, as I said, this was even before our 104 satellites was launched, and it was based on what Mangalyaan did and the likes. And if you see, what he also says is sustaining innovation is when you want to look at a problem is well understood, there is an existing market, innovation improves performance at a lower cost, and then customer is believable, market is predictable. That is a sustaining innovation. But disruptive innovation is problem not well understood, it's a new market, innovation is dramatic and game changing. Customer does not know, market is unpredictable. Traditional business methods fail. And in fact, in another write-up, in the 10 characteristics of 10 disruptive innovation, Bernadette Jiva writes, start with a purpose and work on small ideas instead of big ones. Observe what is being done and not what is being said is being done. In fact, this reminds us all the time when we grew up as children, what children do while they are taught by their parents and they are told so many things. What children actually do is they see what the parents or elders are doing, they imitate them. So even in innovation, what you need to do is the same way. Don't simply follow what is being told, but you observe what is being done. And then use data extensively to learn of trends. Big data has a role to play. Be more responsive to customer needs and behavior. Look at what customer really needs, not what he claims he needs. Then, okay. Then I'll quickly complete this. Try to change the fringe group first and attempt to cover the others later. First understand the fact, then attempt the obvious. Disruptive innovation is going to make a big impact on the way business and organizations from the world are going to influence humanity and development of coming influences. Just a small example of what happens. You can see in 1998, Kodak had 170,000 employees and sold 85% of all photo paper worldwide. and then within a few years, their business model disappeared and they got bankrupt. What happened to Kodak will happen in a lot of industries. It's anyways always in the future it's going to happen. Then digital cameras were invented in 75. The first ones only had 10,000 pixels, but following Moore's law, a lot of things developed, and then today what you are seeing is very significant. So artificial intelligence, health, autonomous electric cars or flying cars, education, 3D printing, and many other things are the things. Fourth industrial revolution are all the things that are going to be the place where you can actually make a huge impact. In fact, what I have tried to showcase to you is that India, and by virtue of what a great visionary scientist like Dr. Vikram Sarabhai, son of the soil of Gujarat, had a tremendous foresight and vision to look at how a new technology of going to space, putting objects in space, could be used for the benefit of the country, both in its development and meeting its primary requirements, and in the process, how the accessible technologies was used, what was not accessible was built indigenously, and with that, showcasing to the world that while you are using that accessible technology and available technologies, you show to them that you can do things differently in an innovative manner, and through that process, make an impact. And what is ahead of us, particularly after what the pandemic has done, it has changed the entire mindset of every individual, particularly of the governments. Today, India as a whole is looking at how the entire country can become Atmanirbhar, and in that process, not only meet the requirements of the country, but also become a significant player in the global economy, and through that provide more and more opportunities for our entrepreneurs to work and then provide solutions to both India's problems. But India has never been looking at India in isolation. True to our heritage, our entire ethos is that the life on planet Earth is one single entity. We cannot be separating it, and we need to understand that whatever developments we do, at times we may be doing the developments at such a pace that it causes unsustainable activities on planet Earth. And unless we take note of this and worry about sustainability and living on this planet Earth is an entity which we have to worry about. If we keep this in mind, India will again be true to its own heritage, a world leader in the coming days. And in this, you have a tremendous opportunity, and entities like iHub is promising to provide unique opportunities to the entrepreneurs in Gujarat to make this happen. So let me wish both iHub as well as all the entrepreneurs out there a great success in achieving what you set out, and wish you all a great future. Thank you.
Thank you so much, Dr. Kiran Kumar. It was a wonderful listening to you. It was like a movie, seeing through how the space program came from that small rocket that the early founding fathers of ISRO took in a cycle in Kumba, to the advanced technology programs that all of you are leading together. And ISRO is one of the organizations which makes each of us, each single Indian, proud, because it's not only an institution of eminence, but it also take high technology for impact at grassroots. And that's the beauty how, as you mentioned, that the bunch of fishermen who allowed the initial team of ISRO to experiment and set up now the entire 7,000 coast of fishing, and all fishermen are benefiting. So this is a truly remarkable journey. So with your permission, sir, we would like to take some questions.
Sure.
And maybe that will be really interesting. So one question, sir, is you have been very vocal about how using space technology we can harness solar energy in the space. You know, you call it as a solar farming in the space, right? And you say that it's quite efficient and it can really be a big path-breaking thing in terms of the power consumption as a country like India is concerned. Would you like to highlight how that is important, the solar farming in the space?
Yeah, see, one of the key things is it's a concept where on Earth, when you get solar energy, almost like 1360 watts per meter square amount of energy which comes, if you actually it has to pass through the atmosphere, and also because the Earth is rotating, the amount of time sunlight falls at a given location is limited. Now you imagine if you are in space, then you can continuously point towards sun. So you have got a 24/7 availability of sun. Next is whatever atmosphere was attenuating or restricting the amount of sunlight reaching. So that also gets reduced. So these two huge advantages you get. But then converting sunlight into a form of energy which can be harnessed and transferred to Earth becomes the problem. And also in harnessing the solar energy into another form of energy which can be transported is another challenge. In fact, work is going on globally on both these directions. And ultimately, anytime what succeeds is only when you make something economically viable. Today, if you have to build a solar farm in space, you have to visualize that if you have to build that system in space, your ability to move things from Earth to space, your launch vehicle technology should become very cost effective. You should be able to move significant amount of weight and volume at very low cost. At today's cost, it is not viable. And then similarly, to what form of energy it is converted, whether it's microwave energy or in other forms, and then transporting it to Earth is the other issue. So in all these areas, as the technologies keep developing, as newer capabilities come in future, such a thing will happen. Definitely the advantages are there. Economics and then innovations and research is what is going to make it happen on a future date.
Wonderful. Sir, you have been very vocal that somehow, even for the growth of space technology, we need to have public-private partnership, and that's quite kind of important in taking this thing forward. In fact, the Union Cabinet announced the formation of Autonomous Nodal Agency, the Indian National Space Promotion and Authorization Center, an extension of ISRO, which is aimed at including private players to come and assist in the space domain. Would you like to highlight something more on that?
Yeah, so like I pointed out, what India in terms of space technology is among the very few countries in the world which has an end-to-end capability of building rockets, satellites, going to space and using it for various activities. So it's a technological capability which the country has built, not only by virtue of what ISRO has done, ISRO has also actually used the support of industry in doing this. But then today, capability demonstration has happened. But then what is needed is capacity to be a player in the global space economy. Like I said, it is almost $400 billion economy in the world. And then space is the fourth frontier, and it has got tremendous opportunity of exploitation, exploring space, and then even harnessing asteroids, etc., mining. So many things are possible. So towards this, what the government is trying to see is how can we bring in more and more players outside the government to become partners in this, and how government can enable the industry and academia to work. And towards this, these mechanisms are being brought in. And it is both the effort of the government and the entrepreneurs to work together. It's a big challenge. It's not an easy task because there are many challenges in this. Both, as you can visualize, space is a very risky business. The amount of failures that you could encounter before you succeed could be very large. Just to showcase to you, Elon Musk, when he started, in fact, probably he might not have continued if this fifth launch was a failure. Four launches were failures, but then because he had deep pocket, he could continue. And today he has demonstrated that space economy can be done by entrepreneurs outside the governments. And very sure, like the other frontiers, like land, ocean, air, space is also going to be full of entrepreneur-driven, private entrepreneur-driven activities in the coming decades, and they are going to be the key players. So what Government of India is trying to do is enable the people in the country to be partners in this. It's an effort where entities like yours and DOS has to work together and make it happen. So this is a challenging time. The path is not very clear, easy, or it's not well laid out. There will be hurdles, but then the effort, even the long trip starts with the first step. So the government has taken the first step. I'm sure we'll be able to do great, succeed in this effort.
Wonderful, sir. I think we all have to work together. It's not just the government's duty. In fact, the duty is more on the entrepreneurs and startups to rise up to this challenge of innovation. Sir, ISRO has been inviting startups to come up with solutions related to food and medicine for astronauts, green engine, better tools for accessing the machines in spacecraft for its maiden human space flight, which is the Gaganyaan 1. So what are the kind of challenges that we could put to the students for working on these kind of issues?
Yeah, in fact, if I'm not mistaken, already there is a announcement of opportunity which was given by the Human Space Program Office, where they are looking for, see, it's a continuing process, and not only in this, but there'll be opportunities in many other things. So what is needed is probably iHub could also have a series of discussions with our capacity building program office in Bangalore. In fact, we have set up a separate capacity building program office to deal with issues like this. And I'm sure the director there, Dr. Venkatakrishnan, would be more than happy to interact, and also the program officers at Human Space Flight Center will be working with iHub for taking this forward. In fact, the opportunities we have to create, we have to visualize and create opportunities and make it happen. And I'm sure that there will be plenty of such occasions where we can allow the students to make use of their creative minds in many of these problems.
Thank you, sir. I think your suggestion is a very good suggestion, sir. We'll certainly follow up and reach out to them, and also take your support in getting the problem statements and throwing that challenge to our students. I can also share you that we have 2 or 3 student startups within Gujarat who are trying to launch their own satellites and also own rockets, and they have got some success. So that is the kind of confidence that our today's youth are having. So we have to put them to work on the biggest challenges that the country is facing in terms of technology. So there are established markets for the monitoring and removal of space debris, and the revenue for such removal is expected to be like in the range of 2.7 billion. So currently there are more than 2 million asteroids also that pass closer to the Earth. So that market is also very high. So what are the kind of opportunities that is being triggered by this problem?
See, for example, in terms of debris, if you look at, this is going to be a problem continuing, because as the technology is moving, so you have already heard of companies trying to put 12,000 satellite constellation or even 80,000 satellite constellation for providing internet across the globe. That means more and more objects will be getting into space. And then if all non-functional objects remain, they can cause a huge problem. So there are many student groups and also researchers which are trying to bring in some capabilities which will be built into the satellite itself, so that these satellites, after their functional work, will be actually brought into an orbit where they decay very fast, or they create surfaces on those satellites such that decay becomes faster, or there are also companies which are thinking of like scavenging, go to space, capture these objects, and then remove it from space. So these are all tremendous ideas. And then, of course, these are little long-term operations, and you need to work on these concepts, work on individual elements, and piece them together if success has to happen. Like I was telling, everything ultimately boils down to economics of doing. Unless the economics of doing becomes viable, it will not be a successful enterprise. So this is where the real challenge comes. While many opportunities may exist, how to make a economically viable solution for that is the real challenge.
Yes, sir. I think many times we also in this forum discuss about how to make not just an idea or a product, but to make it market ready, and also efficiently we should execute it. So that is an important aspect that we constantly try to the business aspect of the technological innovation and also the commercialization aspect which we are focusing. So the importance of collaboration between academia, research organizations, industries, how we can do it in the space sector, and how this can lead to more Atmanirbhar Bharat.
No, like one of the things we were trying to do is the various centers also showcase the problems in which they are interested, and in these problems taking actually the student group. But one of the problems in directly dealing was the numbers that could be accommodated. As you can visualize, ISRO, by virtue of its own actual strength, does not have enough time among the people to spend with others. So we though have many things which could be done, but because of the ability of the people working within the organization being already loaded with the many things, not being able to spend sufficient time. Of course, this is a challenge. Probably what we need to do is try to make use of even people who have just come out of the ISRO, who are leaving ISRO just in the recent past, and how through them build both within academia and also in the institutions like iHub, where they can be some kind of a consultant, and then they can support or give some guidance to the people, the entrepreneurs. Maybe you could look at such a model where few of the people could work as consultants and then take this forward, both in formulating the problem and also in trying to give some solutions to the problem.
Wonderful, sir. It's really wonderful to listen from the horse's mouth. You yourself has guided the entire space program. Sir, one question. This is something that we used to discuss just before the session. That ISRO is one of the rare organization whose entire journey has never it has always surprised us. You always come up to the occasion and deliver. May it be Chandrayaan-1, may it be Mars orbiter mission. What is that in your DNA? ISRO as an organization, maybe you have closely worked 40 years. That ensures that you keep on delivering high demand success with lowest amount of budgets. People say that the amount of money we make a Hollywood film on Mars, within that same money we make sure that the mission is possible in India. What is that DNA in ISRO which makes it possible?
I think for this, really we should give credit to the father of our space program, Dr. Vikram Sarabhai, who initiated this entire concept of using a technology, new technology for harvesting societal problems. So right from that time, the emphasis, the following people, whether it is Professor Satish Dhawan, Professor Yuvar Rao, Dr. Kasturi Rangan, Madhavan Nayak, or Radhakrishnan, every one of the top leaders and others in the organization, all the time, the whole motto has been how we can use this technology to address problems. What technology is accessible to you, you make use of it. See, Atmanirbhar does not mean not using what is accessible to you. If you have to leapfrog, if you have to make a significant move ahead, you use what is accessible. What is not accessible, you build yourself, and all the time set aggressive targets, work towards that. Though when you set the target, it may not be achievable at that time, But then you are telling everybody who is working, start working towards that. You can actually many times feel how such aggressive target setting actually changes the mindset of the people working. So it is no longer that it is doable or not doable. I'll do everything in my hands to make it happen. So that's the mindset. In fact, in all this, we really need to be grateful to Dr. Vikram Sarabhai, whose birth centenary we just celebrated whole of last year. And it was his idea of how things can happen. It was his management concept, how we brought together a number of people, how he set up competitive activities simultaneously, more than one group working on similar things. So many such things, but more than anything, it is working towards one common end goal, that is how to bring technological capability to address nation's problem. That is the key.
Wonderful, sir. I think what you sum up saying is, the leadership is at forefront, and then the mission is intact. Everybody know that they're a part of the game, and the game is very clear. And I think that's very fundamental. Sir, just to add to what Nagarajan sir told about the external collaboration, I would just like to know a little about the internal collaboration, because many times in Indian context, our engineers and scientists are very excellent individually, but we fail miserably many times to collaborate and do excellent things. How does ISRO manages that? You have 10 centers, you have propulsion laboratories somewhere else, you have you have your remote sensing at one place, your technology development at one place, you are in Bangalore, in Thumba, in Delhi, in Ahmedabad. How does this collaboration happen? How do you manage that?
Yeah, see, like I said again, the entire thing is so whether it's a launch vehicle technology, satellite technology, payload instruments, applications, all along, everybody is seeing the end goal. They are not seeing I'm only doing a satellite, I'm only doing a rocket. In fact, all this concept also, if you see right from beginning, when site experiment was done, or when the initial launch vehicle activities were done, in all of them, we are all looking at, we are doing our part of the end activity, where Department of Space is trying to provide a solution to a problem the country is facing. So it's again goes back to this primary focus which our father of the space program was able to instill, you can say. In fact, it is that which actually, that thread which runs through the entire set of people. And as long as each of us remember that that end goal is what I'm working for, we will continue to succeed. If we are able to bring more and more such ideas and then vision into the system, then India, in fact, now it is really happening in a way. The Honorable Prime Minister is doing the job of system engineering. He is trying to bring in the entire country and trying to make things happen for the country.
Wonderful, sir. Sir, just I will take a couple of more questions to pick up your brain. So one recent news says that ISRO is also planning to set up a lot of incubators in the space in all regions. I think the first one was set up in VSSUT in Sambalpur in Odisha, and you are trying to set up different incubation centers to promote space technology startups in north, east, west, south, and central region of the country. What was the rationale behind this project, sir?
No, basically, see, as part of what you heard, the government is trying to make more and more technological capability enabling in the country. See, India is a vast country. See, many times what is happening is actually not known to the even student community or the enterprise. So as a result of this, what we saw is that in the region, each region, if we set up one mechanism, at least in that region, there will be little more awareness of things that are happening. In fact, whatever is being done is a minuscule thing. It is not going to be sufficient. We need to do it in a much larger scale, like what you are doing in Gujarat, for example, iHub. Similarly, Karnataka is doing in its scale. All state centers are doing. What we need to do is probably work together with each of these state-run entities with the central agencies and then enabling. So the effort is try and make it happen. And it's always, like I was telling, it's a new path. It's not a trodden path. So we do not know how exactly we will find solution, but we need to find solution. So that is the real thing. So where the even Department of Space is attempting to set up these kind of small facilities where the entrepreneur will get the facility of that particular place, laboratory, and then computer systems, and then certain guidance from a set of people working in that region. Under their guidance, the problems can be done both by the academic institutions, students, researchers, and also small entrepreneurs in that region. They can work together. See, for example, I'll just give you one simple possibility. See, today while working, ISRO would have come across a particular problem solving. And we realize that this particular technology can have a very good solution in the market. For example, if you look at today, if you say this fire-resistant paint as part of our heat-resistant tile and many other activities, fire-resistant paint. Now, we would have done the activity keeping our usage in space, etc. But then how to convert this technology into a cost-effective, low-cost paint available to even a small, you can say, tent where you can put this heat resistant so that fire doesn't go up. Or similarly, like lithium-ion batteries, etc. So many of these, so there is a place for the idea which is there to be converted into a manufacturable or product solution. So this is where these entrepreneurs come into picture. So we are trying to provide such opportunities to them, showcase to them, can you look at this problem and find how this can be used in the industry in a different way, how this can be used in the other application. So it's a huge challenge. Right now, even identifying all such problems within the organization is also an effort which is going on.
Wonderful, sir. In fact, this is very ambitious and pragmatic, and this is the way forward. And this is how probably our broader roadmap of innovation works. Sir, before I request Nagarajan sir to propose the vote of thanks, I have one last question from the audience to you. Dr. Kalam had a vision for Vision 2020, and ISRO is one of the institutions which has really stood up to that expectation. You have been personally involved in ISRO for 4 decades. How do you see ISRO moving forward in the next decade to come? Why do we stand in the global space technology and innovation mission? What is your dream of seeing ISRO there down the line decade?
Actually, if you look at this particular problem, what you are posing, see, more than what is our vision for future, see, ours is an effort which is a continuously evolving effort with the prime objective of, like I said, space technology as a tool for nation and global development. As the frontier keeps moving ahead, the task for Department of Space is going to grow. See, today, one of the key changes that is happening is not just as a department of government organization, how to enable the entire country to take advantage of the space technological capabilities. That means we need to build more and more technological capabilities. You need to look ahead. Both, see, actually space frontier also brings in many problems. See, as the country's economic strength grows, even right now you are seeing that we have many problems which we are facing across the geopolitical entities. So space again becomes a very important component. So in all this, while the desire could be that we want to do many things, we also need to make sure that we do not lose track of what is our prime objective and keep working towards enabling use of space technology for addressing all the issues we face with what could be solved from space. So I would like to restrict it to that. And right now, I would not like to go too far ahead and say, by this time, this should happen. But one key thing is that all the time, we should make use of what technology is accessible to us, what we need to build our own, put our priorities right, and move ahead. If we do that, we will actually gain not only strength, but also we will move ahead of others.
Thank you so much, sir, for laying down the fundamentals to be correct. The bottom line is fixed. And I think this is another reason why ISRO has delivered, because the macro vision and the fundamental layer that you set out is really wonderful. May I now request Mr. M. Nagarajan, Commissioner of Higher Education, Government of Gujarat, to offer a formal vote of thanks to Dr. A.S. Kiran Kumar.
Thank you. Excellent, sir. It has been a very, very wonderful session. On behalf of Education Department and all the participants here on Zoom and Facebook Live, I extend a very warm thanks to you. You have taken us through the journey of space development and the journey of ISRO, and also you have taken us into the space and into the future. Thank you very much for enlightening us with your insights, and we hope that you will keep guiding us in the future in our other endeavors, and also inspiring us to do something, especially in collaboration and innovation space and the new opportunities that are being thrown up today. Thank you for spending time with us today in this Sunday evening, sir. Thank you so much for joining us. And I also thank the iHub team for putting this all together in this excellent webinar. Thank you.
Thank you so much, Nagarajan sir. Thank you so much, Kiran Kumar ji. Namaste.
Namaste.